Hi, this is Dr. Jessica Dunn, and we're going to discuss loan amortization. Loan amortization pulls all of the time value of money techniques together and shows you exactly how a loan breaks down. So, we're going to first determine the equal periodic loan payment necessary to repay both the principal and the interest of a loan back during a specific period of time. With this, we are going to calculate a loan amortization schedule. So this is the actual breakdown of how the payment will be allocated each month between the interest component and the principal debt component. And you will see how that affects the loan balance and the loan amount due each month um, throughout the life of a loan. So the first step in loan amortization is to calculate the actual payment. So we need to determine how much should you pay each month in order to get this loan paid off, both the principal and the interest, in a set amount of time. To do that, we are going to use the payment button on our financial calculators because a loan qualifies as an annuity because the qualifications for an annuity are that they are equal, periodic, and finite. Now with loans, the payments are always equal. You can expect what you're going to pay every month because they don't change. They are periodic. They're always due at the same time each month, and they're finite. At some point, this loan will be paid off and you will have no more obligations. So here's the formula for doing this. You don't have to know the formula. I'm going to teach you how to do it on your financial calculator. But cash flow or payment is equal to the present value times the nominal rate divided by 1 minus 1 divided by 1 plus the rate raised to the number of years. Now, of course, this formula assumes annual compounding, which is the assumption that we're going to make to start with to make the calculations easier. Then we will relax that assumption and look at monthly payment obligations. So let's start with this example. Let's say that you borrow $6,000 at 10% and you agree to make equal annual end of year payments for 4 years. What is your payment? So just like every other problem, let's put this on a timeline and see what it looks like. So today we are borrowing $6,000. So that $6,000, that is a cash inflow to us. We have that money to spend. So that's a positive number. We are going to make annual payments of this to this account. We're wanting to determine how much we should pay every month so that in the final year our balance is 0. So let's start with the easy stuff. N is m times n, and our m in this instance is 1. So 1 times 4 is 4. Our rate is our 10% divided by our m, which is 1, so that gives us 10%. Our present value is $6,000. That's how much we are going to be receiving, and it's a positive $6,000. And our future value is 0 because we're going to pay this loan off. So let's calculate our payment. So our first step is to clear a time value of money. We have 4 periods, 10% periodic rates. We're borrowing $6,000, and we're going to pay that off. So let's compute the payment. We have $1,892.82. The negative makes sense because to us that is going to be a cash outflow. We are going to have to pay this every year. So that's our annual obligation for this loan. So now let's look and see how that breaks down. So let's create a loan amortization schedule. We'll see how that payment, that $1,892, is broken down into the interest and principal components each year. So we have 4 years we're going to look at. We have our beginning balance. And for year 1, at the beginning of the year, we owed $6,000. We made a loan payment of $1,892.82. We need to determine how much of that payment goes towards interest, how much of that payment goes towards principal, and what is our resulting ending balance. So the interest, to calculate that, it is equal to the interest, the periodic rate on our loan, which here is 10%, multiplied by our beginning balance. So for this, it's going to be 10% times $6,000, so $600. Our principal is equal to the loan payment minus what we paid in interest. So here it is that $1,892.82 minus $600, so that gives us $1,292.82. Our ending balance is our beginning balance minus principal. So our 6,000 minus 1,292.82, and that gives us $4,707.18. Our beginning balance for year 2 is the ending balance from year 1. Our loan payment stays the same. The interest is calculated the same way, 10% times our beginning balance, so $470.72. Principal is the loan payment minus the interest, so $1,892.82 minus $470.72 means that we paid down our loan by $1,422.10. Our ending balance is equal to our beginning balance, that $4,707, minus the amount we paid on principal, $1,422, to give us $3,285.08. And the process continues. The beginning balance is our ending balance from the previous year. Our payment stays the same. 10% times the beginning balance is $328.51. That means the remaining of our payment goes towards principal, which is $1,564.31. Our ending balance then is our beginning balance minus that amount that went towards principal. So $3,285 minus $1,564, and that gives us $1,720.77. That is our beginning balance for year 4. Now this may look confusing here because our beginning balance for year 4 is less than the actual payment. But don't forget that this was our beginning balance at the beginning of the year. This is our payment at the end of the year. So we do have to pay interest on this loan during the course of that 4th year. So our interest is $172.08, which is 10% times our beginning balance. The amount that goes towards principal then is our beginning balance, or I'm sorry, our loan payment minus our interest. So $1,720.74. And so we have a difference here of 3 cents. And that's often true. You'll often find that the final payment may differ from the others by a few pennies because of rounding. So with this loan amortization schedule, there are a few things that I would like to point out. The first is that we see that the amount of our payment that goes towards interest every month is decreasing. So we see that the interest component of our payment decreases every month, or every year in this instance, And that's true with all loans. As we progress through our payment schedule, the amount of our loan that goes towards interest reduces each year or each period. That's because our principal balance is also decreasing. And that interest calculated is based off that principal balance. So the opposite is also true. As we progress through our amortization schedule, we find that the amount of our payment that goes towards principal increases. So you'll find that your principal payment increases. So that's why it's very beneficial if you can scrape together a little bit of money and pay extra on your loan each month, even if it's only, 20 bucks. That greatly reduces the amount of interest that you pay over the life of your loan because it is forever reducing the principal balance because that extra payment that you make goes directly towards principal and reducing your principal balance, which is what your interest is calculated off on. So it helps you to reduce that obligation much quicker. So you can actually do this on your calculator as well. I just wanted to teach you how to do it on paper first, so that way you understood where it was coming from. But you can do all of these calculations on your calculator, and let me show you. So we already calculated a loan payment. If you don't remember how we did that, let me refresh your memory. We had a 4-year loan at 10% interest. We borrowed $6,000 and we're going to pay that off. Let's calculate the payment. Once you calculate the payment, don't clear this screen. We're going to use this amortization button that you can find right above the PV. So second amortization. Now here it's going to ask you P1 and P2. P1 is the beginning of the period, P2 is the end of the period. So if we want to see what happens in year 1, we want to see what happens from the beginning of year 1 or period 1 to the end of period 1. In this instance, periods are years. If this were amortized, if this were compounded monthly, then to see what happens in year 1, you'd have to go from period 1 to period 12 because each period is 1 month. So now that we have calculated this, we can scroll down. Notice how this matches up with our loan amortization table. We see that at the end of year 1, our balance is $4,707.18. The principal that we paid is $1,292.82. The interest that we paid is $600. Let's see what happens in year 2. So from the beginning of year 2 to the end of year 2. Oh, clear that. Enter to save. We paid $3,285. That's our ending balance. The principal that we paid is $1,422. And the interest is $470.72. So it saves you a bit of time here. Now the nice thing with this function is that you can see what happens over the entire life of the loan. So we can see what happens from the beginning of year 1 to the end of year 4. Our balance is 0. We've paid this loan off. We've paid $6,000 in principal. And we have paid $1,571.30 in interest, which is the sum of this interest column. That's the amount of interest we've paid over the life of this loan. So it makes it really interesting. It lets you be able to see exactly what you've done and how that affects your loan balance month over month or period over period. So sometimes it's interesting to find growth rates. So this would just be solving for IY instead of solving for payment or future value or present value or N. It just lets you solve for IY. And it's really interesting whenever we want to see like what is the interest rate on this loan. So that's a real world application. We want to know what interest rate we're paying on a loan so we can calculate the interest rate on that. But here let's start with this example. Ray purchased an investment 4 years ago for $1,250. It is now worth $1,520. What is the compound annual rate of return he earned on this investment? So let's do a timeline. 4 years ago, he purchased an investment for $1,250. He spent $1,250 on it, so that's a negative. 4 years later, it's worth $1,520. We want to know what rate of return we've earned. So N is M times N. This is compound annual, so our M is 1. So 1 times 4 is 4. Our present value is a negative 1,250. Future value is a positive 1,520. And our payment is 0 because we're not making any other contributions. So let's calculate our growth. So I'm going to clear my time value of money. We have 4 years. We made a $1,250 investment that's now worth $1,520. And we've made no other contributions. So let's compute our interest rate. We have earned 5.01% compound annual rate of return. Jan can borrow $2,000 to be repaid in equal annual end-of-year amounts of $514.14 for 5 years. She wants to find the interest rate on this loan. So she can borrow $2,000 today. That's positive because that is money that she is receiving. She is going to pay $514.14 every year. And she wants to have a $0 balance on this loan at the end of the 5th year. N is M times N, but this is an annual, so our M is 1. So 1 times 5 is 5. Our present value, 2,000. Our future value is 0. And our payment is equal, periodic, and finite is a negative $514.14. Now, if you don't get your positives and negatives right, you will get an error of 5 on your calculator. Error 5s are usually always a result of sign change problems. And so if you get that, you can pretty much know that there should have been a negative somewhere and you missed it. Okay, so I'm going to clear my time value of money. We have 5 years, borrowed 2,000, paid it back at $514.14 a year. We have a $0 balance at the end of the 5th year. Let's compute our interest rate. We have a 9% interest rate on this loan. Sometimes we need to calculate the amount of time it takes for something to happen. So we need to solve for N instead of one of the other functions. Ann wants to determine the number of years it will take for her initial $1,000 deposit earning 8% interest to grow to $2,500. So here today we have deposited $1,000. This is a negative because we took money out of our pocket and put it into a savings account. We want to know how long it will take for that investment to grow to $2,500. So our N, M times N, our M is 1. And that's what we're wanting to solve for years. We deposit $1,000 and we want to withdraw $2,500. The interest rate is 8%. Let's calculate time. So first step, I'm going to clear my time value of money. Depositing $1,000. I want to withdraw $2,500 and 8%. And we're adding nothing else. Our payment is 0. So let's compute N. We get 11.91 years. Our payment was 0 because there were no additional contributions. So let's do another example. Bill can borrow 25 grand. He can borrow it at 11%, making equal end of year payments of $4,800. How long will it take him to fully repay the loan? So let's draw a timeline. Today, he is going to borrow $25,000. So that would be a cash inflow to him because it is money that he can put in his pocket today. And at some point in the future, it's going to have a loan balance of $0. To make that happen, he can pay $4,800 a year. So let's put in what we know. We know that n is m times n, and our compounding frequency is 1. Our interest rate is 11%. Our present value is a negative 25,000, and our future value is 0. To reduce this loan balance, we're going to pay $4,800 every year. So let's work this out on our financial calculator. So the first thing I'm going to do is clear my time value of money. We have 11%. We've borrowed $25,000. We're going to make annual payments of $4,800. We're going to have a loan balance of 0. Let's compute time. So 8.15 periods. In this case, periods are years. Okay, so let's do one more example. Let's look at a problem with monthly compounding. So let's say John borrows $1,500 at 5% for 2 years. Payments are due monthly and interest is compounded monthly. He wants to determine the amount of interest he will pay over the life of the loan. So let's calculate first. We need to calculate what the payment is on this loan. So let's draw a timeline. Today, he borrows $1,500. He is going to make monthly payments. And at the end of those 24 months or 2 years, he will have a loan balance of $0. So every month, he is going to be paying some amount, and this is what we first want to calculate, is the amount that we're paying. So our n is m times n, compounding frequency times years. Our compounding frequency is 12 because it's monthly. There are 12 months in 1 year. So that's 12 months times 2 years, so 24, which is what we had already talked about. Our interest rate, we need our periodic rate. Our nominal rate is 5% and it's compounded monthly, so 5 divided by 12 is our periodic rate. We borrow $1,500 and we're going to pay that off. So let's calculate our payment. First, clear our time value of money. So 24 months, 5 divided by 12 is IY. 1,500 is our present value, and 0 is our future value. Let's compute our payments. We get $65.81. Negative makes sense because we are paying $65.81 every month to repay this $1,500. Now, he wants to know how much interest he's paying. So let's use our amortization schedule to do that. So we'll do a second amortization. This is a 24-month loan. So period 1 would be the beginning of month 1. Period 2 would be the end of month 24. During that period, he has a $0 balance at the end of the life of the loan. He has paid $1,500 in principal, and he's paid $79.37 in interest. If instead he had said, well, I want to know what is the interest I'll be paying in the first year. Let's go back, or let's continue scrolling. Period 1 would be the beginning of the first year. Period 2 would be the end of the 12th month, so the end of the first year. At that point, he still owes $768.71. He has a $731 principal balance, and he has paid $58.39 in interest. So our payment was $65.81, and to answer this question, it was second amortization, period 1. Period 1, enter. Period 2 would be the end of the second year, so 24 months. $0 balance, paid $1,500 in principal, $79.37 in interest.